Hi, thank you for being with me again. Just now in the previous video, we stopped at step 2, right? Now we want to determine the head losses in the two branches. Okay, in branch A, it's stated like this. So let's see what is the meaning of these losses. Okay, so we have 2K, K1 times VA to the power of 2 over 2G. So where this comes from? Okay, let's see here. Okay, this K1 is actually the resistance coefficient for each gate valve. So we have two gate valves here. One gate valve and two gate valve. Okay, which is why you have 2 in front of this K1 because you have two gate valves. Okay, so K2 is the resistance coefficient for the heat exchanger. So this value 7.5 is given. So this is the loss from the heat exchanger. Okay, so the following data are known because in finding gate valve losses from gate valve, I mean the value of K for gate valve, you will need this FT. Okay, so this is known. This is the values 0.019 for a 2-inch schedule 40 steel pipe. So this is the type of the pipe. That's why you have this value of FT. You can refer this to the table that I showed you from my previous lectures. Okay. Okay, so for this one, okay, so this is actually not FT. In the textbook, it's given you like this, but this is actually LE over D. So LE over D is equals to 8 for a fully open gate valve. Okay, so this is also from the table. Okay, what happened in the branch B? Okay, because this is all for branch A. Because here it stated earlier that the friction losses is neglected. Okay, so let's look at branch B. What do we have in branch B? Okay, in branch B, you have how many types of losses? Okay, we have K3. So K3 is resistance coefficient for each elbow. So we have two elbows here, 1 and 2. Okay, so that's why you have this 2K3 because this is for elbows. Okay, so times 2VB to the power of 2 over 2G. And then you add with K4. K4 is resistance coefficient for the globe valve. So we have a type of globe valve here. Okay, and then this is the formula for calculating globe valve. And then next we have K5. Okay, K5 is for this one. This is friction loss. Okay, so this is the major loss, and these two are minor, right? So these two friction. This for this one, this K5 is the friction loss for branch B. Okay, let's look. What is the value of FBT? Okay, so this is since it's 1/4 inch schedule 40 pipe, so the FT from the table is equals to 0.022, and LE over D for each elbow, okay, is 30, and the other one for fully open globe valve is 340. Okay, so all this you can make your own revision. If you didn't remember how to do this, you can make revision from my previous lecture. Okay, by having all these values, we can calculate K3, K4 and K5 and plug in this equation. Okay, so since we have friction loss in branch B, so we have FB. Okay, so finally, after you put all this information, the K in this equation, we have this equation. Okay, so this comes from the losses from pipe branch A, and this is from branch B. Okay, so as usual, we have so many unknowns here. First, you don't know VA, right? and you don't know HA, the losses. And you also don't know HB, and you don't know VB. And there is one more parameter here that you don't know. The variable is FB. Okay, as usual, this is where the iteration method comes very handy, yeah, because you need after this to determine VB, VA, yeah. Okay, so as we did in previous example in the lecture before, we have to use iteration method. Okay, so okay, this value is given first of all. Okay, so later we will need to use this and use it with Moody diagram. So you don't know FB, so first you must assume your first FB. Okay, so this is the first FB. So the first FB is 0.023, and because you need to assume this F value because you want to determine the velocity. Okay, let's look at how we determine the velocity. Okay, so you have two equations, right? HA and HB. So you know that HA and HB is equal. So this is equal. So once you have FB, so you can solve this question, this whole question, and this becomes this one. Yeah, once you have the FB, you can get this equation. Okay, and this is for HA. Okay, oh sorry. Okay, this is for HA. Okay, and this is for HB. Okay, so now you can know VA in terms of VB. So VA is equals to 1.281 VB. Okay, so you use this value of VA in this equation. So what is this? This is Q1. You know that earlier Q1 is equals to VA plus VB, QA plus QB, right? So this is the equation. So now you put this VA value in this equation, so you will get this equation. Finally, VB is equals to 1.281 A. This is the area of A plus the area of B. Okay, so now you have to solve for VB. Okay, so when you solve for VB, you get this value for VB. And once you know VB, you can calculate V velocity of A in pipe A. Okay. Okay, so this is the first iteration where you assume this F, right? Which is 0.023. Okay, so you know that one iteration is not enough. You have to check whether this iteration is correct or not. So with this V value, you use Moody diagram and calculate the Reynolds number, and then you have this, okay, together with the relative roughness and Reynolds number. So you can check whether your F calculated from this part, whether it's equal with your F assumed. Okay, let's check. Okay, so now I don't show you the Moody step to find F, and I will not show you the iteration because it will take a long time, and some more you already know how to do this, right? Okay, so this is the first iteration. In the first iteration, okay, we assume that the value of F is 0.023. So we got velocity at A and velocity at B. Okay, so from here you check the new F. So from the F that you calculated, then you find 0.025. So here you know that 0.025 is not similar with 0.023. Okay, so you have to do the second iteration. So in the second iteration, you use the value of 0.025 for f as in the second iteration to find VA and VB. Okay, so once you have the VA and VB, you use Moody diagram, you calculated the Reynolds number, and you use the relative roughness and check new F, new friction factor. So your new friction factor will be 0.023. Okay, so here we can stop the iteration because this is similar with the first F that we guessed. Okay, so this is how you have to do it. My God, what happened? Okay. Okay, so since this is the last value that we accept, and we accept because this is not different with the first value that we assume, so VA and VB in this case are accepted. Okay, so with VA and VB accepted, we can find QA and QB. Okay, so this is the first question. Yeah, the first part of the whole question. Okay, so I hope this is easy for you. I hope you can follow this. Okay, so next find the final step. Okay, the part B, which is to find the pressure drop. Okay, so now we have to determine the pressure drop. How do we determine the pressure drop? Of course, simple as before, we just apply the energy equation between point 1 and point 2. So we have this energy equation, and you know that all these terms are 0. I mean, they don't have to be included in this. You can look again at the figure, and what are left now is only P1 over specific weight minus H loss that we calculated before equals to P2 over specific weight. Okay, so since the question wants us to find pressure drop, so this is what it means. Pressure drop is P1 minus P2. Yeah. Okay. So you know that HL in this parallel pipe system is equals to HA and is equal to HB. So since you have your V, so it's up to you whether you want to find from HA or from HB because it is similar. Okay, so for in this case, the textbook it uses HA. So the HA is equals to 6.14. So this 6.14 can be used in this equation. So the question just now was to find pressure drop. So pressure drop is actually the difference between P1 and P2. Okay, so this is pressure drop. Okay, so you multiply the specific weight at 50 degrees Celsius. Okay, this one. Multiply by HA. Okay, because this is also the HL, and you multiply by 1 feet. This is just to change the unit. So in the end, because in the end you want to find the unit in PSI. So this is the final answer for this problem. The pressure drop is 2.66 PSI. Okay, so normally my question for you will be in SI units, but in this example you have the American unit, but it is not a problem at all because you can use both the same formula for calculating the answer for any units that you need to find. Okay, so that's all for today and for this part. Thank you so much.